I hope everybody is ready to be wet and wild as we dive into this episode of the Science of Monster Hunter, where we'll be talking about Mizutsune. Uh, I'm a researcher specializing in ornithology and paleontology, and I also really love Monster Hunter. So let me take you through some of the notes and sketches that I've made after Title Update 1 of Monster Hunter Wilds. So the binomial name that I've given to Mizutsune has two components, as all binomial names do. We have the genus, which is Sabovulpes, which means soap fox in Latin, because Mizutsune is Japanese for water fox, or it's a portmanteau of water and fox in Japanese. So I just took that and translated it to Latin, and then added soap. And then for the species name, I've called it Viprodon, which means viper tooth, because just like a viper, Mizutsune has these very bizarre muscles that retract the front of the fangs in its mouth so that they can close properly. So the first thing that I want to talk about with relation to Mizutsune is the big fins on the back of its head, and how they relate to potentially its mating, and what those structures really are. I decided to interpret Mizutsune as an archosaur based on the fact that this jaw muscle that it has inserts behind the jawbone, like in archosaurs, rather than outside of the jawbone in mammals. It doesn't really have a sagittal crest on top of its head like a big predatory mammal would. It also has this antorbital fenestra, or at least it seems to, because it has an indent between its eyes and its nose and the skull. So I have interpreted the fronds on its head as being attached to these processes on the quadratojugal and the postorbital bones, which hold up sort of the back of the skull in archosaurs. And I would assume that they're articulated through the same muscles as like the rest of the face. So they're probably attached to some facial muscle, and they're just kind of big globs of tissue. So why are they there? What advantage could that possibly have for something that's sleek and interested in trimming down as much mass as Mizutsune? It turns out, actually, that Mizutsune have those fronds because they're highly sexually dimorphic. Male Mizutsune have those fronds, presumably as display structures, and they're very brightly colored in the males, but in the females, they're much smaller and duller. And the fact is that every Mizutsune we fight in the games is male because they all have those brightly colored fronds, and something about the male's behavior is driving them to be more aggressive and more dangerous to humans than the females, which is why we see them so much more often. The female Mizutsune are reported to be much more gregarious, much more shy, and they also maintain much smaller territories, and I'll get into why they do that in a second. When two individuals of the same species have different coloration or different structures based on their sex, we call that sexual dimorphism. Here you can see it in these ducks. The male has this very bright, very ostentatious coloration that it'll try to use to impress the female, who is colored more drab because her lifestyle is more adapted to that drab coloration. Females generally nest guard, and for them, having camouflage is much more important than being bright and impressive and signaling good health and mate viability. And this makes sense because Mizutsune mating is highly, highly competitive among the males. They go into something called musth, which is a behavior observed in a lot of elephants, where the males will go through a hormonal cycle once a year, become incredibly aggressive, and they'll, produce a bunch of really, really strong scents and hormones. Their testosterone levels will go up to 140 times their normal testosterone levels, and they'll start to maintain very wide territories, and they won't just attack other male elephants. They'll also start to go after other species of animals. So here are some examples. We have two Asian elephant males in musth fighting each other. Like I said, because this big hormonal change makes them very aggressive. And we have an African elephant engaging in interspecific combat with a large giraffe, which is really, really bizarre to see. And here's an example of Mizutsune doing something very similar, where we can see it's going after Uthduna here, which is, I guess, our giraffe for the sake of example. Mizutsune is setting up a territory in the Scarlet Forest, and it's not just worried about driving out other male Mizutsune, it's worried about driving out basically everything larger than a bread box. This is an incredibly aggressive animal when they get all hormonal, and they're very interested in maintaining that large territory because it will net them more mates, presumably. If Mizutsune females are gregarious and they wander, if you have a larger territory, it's more likely that females will come through your territory and you'll be able to secure a mate without any competition, which is very advantageous. But securing that large territory necessitates a lot of aggression out of the male Mizutsune. If we switch our focus for a little bit, we can take a look at the skull of Mizutsune, and I'll talk about how it's very well adapted for an aquatic lifestyle. You can see, first of all, that Mizutsune has these feelers that are sitting above and below its skull, and they're very, very much a characteristic of an animal that's sitting underwater and searching for fast-moving underwater fish, because those feelers are going to be able to pick up vibrations in the water and give Mizutsune information, even if it's in dark, murky water like the Scarlet Forest during the inclemency, if there are fast-moving fish around it that it can chase after. Mizutsune also has teeth that are very, very specialized for taking fish. Usually in animals that are preying on land prey, they'll have more blade-like teeth if you look at them from the top. Well, they'll have like a specific blade here, and then they'll have serrations running up the side, and they'll look kind of like this in cross-section. They'll usually be curved with serrations on one end. But in fish-taking animals, they'll have teeth that look round from the top, and they'll have no serration. They'll be just kind of pegs that stick out, and a lot of the time they'll be very long. So if we look in Mizutsune's mouth, we see it has these kind of straight, backward-facing conical teeth interspersed with these short cutting teeth for like rending flesh and tissue. And then it also has these very large fangs in the front of its mouth that it's presumably also using to skewer fish. Another interesting thing about Mizutsune's dentition is that it has this gap between its main series of teeth and the front fang. In biology, we call that a diastema, a tooth gap, and it's present in a ton of animals that are taking small, relatively small fish out of water or otherwise taking prey that are a lot smaller than their bodies. So here are two examples of specialized fish eaters. Over here we have a phytosaur. These guys are early Triassic reptiles. They're kind of related to crocodiles. They're within Archosauria. It's debated how closely related they are to crocodiles, but you can see they have these long, kind of peg-shaped teeth, very similar to a modern gharial. And then here, Spinosaurus is a very well-known fish eater from the late Cretaceous of Africa. And you can see here Spinosaurus has these main teeth here, and then it has the fangs up front, and then what does it have in the upper jaw? Just like Mizutsune, it has a diastema, which is going to help it grab those small animals and really secure them while it's looking for a bite. Moving down the body, we can take a look at these forearms. One thing really sticks out to me is it has this gigantic claw. In a lot of fish-eating animals, we'll see like long claws that are usually used for tearing the prey apart, but a lot of the time Mizutsune just eats these fish whole. So I reason that this claw is probably used for territorial conflict. We see something very similar in lots and lots of birds will have very big foot claws that they use to compete for mates with each other. And with Mizutsune, I definitely imagine this is the same thing. We see a lot of Mizutsune with cuts up and down their faces. Sometimes they're called Soulseer Mizutsune in the older games, but now they just seem to be part of the tempered system. And what that indicates to me is that these guys are frequently cutting each other in the face with these claws and giving each other, frankly, very grievous injuries, which impair their sight in a lot of cases, and I'll get into that in a little bit. When we're looking at Mizutsune's body as a whole, it's a very streamlined, very hydrodynamic animal. It has this like big area of shaggy hair that absorbs water rather than kind of keeping it out, which is what you see in animals like cormorants, where they'll have feathers that don't have as much oil as you would expect. So their feathers get wet and they actually act as a ballast because air-breathing animals take in a lot of air to stay underwater, and so they need something on them to make themselves heavier. And so that ballast can help kind of equalize their weight and just give them a little bit more mass so that they can stay underwater more easily. So Mizutsune has these hairs that absorb water and stay heavy. They also allow it to take water with it onto land, which is important because it uses soap in a lot of its attacks. It has these kind of short legs, which are very characteristic of swimmers. They have short arms and legs, and then it is a tail-propelled swimmer. So it's using this big, long tail in motions very similar to stuff like Lagiacris, where it's sweeping it side to side and up and down to kind of push itself through the water, which it can do very effectively. Now I want to talk a little bit about the chemistry of Mizutsune. How does it really produce that soap? A lot of animals actually produce the basic components for soap in their bodies naturally, but with Mizutsune, we actually have to go through the trouble of combining them together. So Mizutsune, I'm assuming, like a lot of other animals, probably produces sodium bicarbonate in its pancreas to neutralize its stomach acid. So that's here. The stomach is up here, and then it's emptying into the duodenum of the intestine. And so this pancreas is producing sodium bicarbonate, which then can be heated up by Mizutsune's presumably very high body temperature because it can light stuff on fire with that eye, or through some other process it's heating up the sodium bicarbonate, which is going to turn it into something called washing soda. And then that is going to combine with lipids in the skin to create soap, because by mixing washing soda and lipids, you can create a soap. So here's a little summary of that process. Sodium bicarbonate into washing soda, into soap, which it then mixes with the water in its tail. So now let's talk a little bit about some of the uses for those bubbles. Mizutsune, in a lot of cases, like I said, lose their sight. And one really, really bizarre use for those bubbles when they lose their sight is bubble-based echolocation, which they might use even when they can see in like dark environments or certain other conditions where sight is not that important. They already have quite small eyes, and so they don't really seem to be using vision as their primary method of predation. When Mizutsune don't see, they kind of push out bubbles and then they listen for those pops. And the popping sound can tell them about their environment and what sort of things are moving through it. If a Mizutsune sends out a bubble straight forward and it pops really quickly, it can tell how far away the surface is in front of it. And because it can put out so many bubbles at one time, and it presumably has very sensitive hearing, Mizutsune can get a lot of information from its environment just from those little soap bubbles. Another use for these bubbles is a behavior called bubble net hunting. This is seen in a lot of humpbacked whales. Not all of them, because it is a learned behavior, it's not instinctual, where these whales will produce bubbles under a school of fish, which because of cavitation, which really, really disturbs these fish, it's a big pressure change moving through the water, it freaks the fish out, they get stuck, and they get forced up to the surface or trapped, and then the humpbacked whales will swim underneath through that bubble net, and then they'll just take the fish out of it. And Mizutsune does the exact same thing in the freshwater areas of the Scarlet Forest, where they're deep enough. Mizutsune dives down, makes a bunch of bubbles at the bottom of the water. As they rise to the surface, the fish panic. Mizutsune jumps up through the middle, and it takes fish that way. So it's very, very inspired by the real-life behavior of these humpbacked whales, and that seems to be probably the main use of Mizutsune's bubbles. So yeah, here's my little diagram of Mizutsune that I did. If you want the actual scan, it's available on my Discord, but that's my little project that I'm doing for the Science of Monster Hunter. I've got about 25 entries on my journal now, and I'm very excited to make many more. So please let me know if you have any questions or if you have any suggestions for future entries to the series, because I do love to hear everybody's opinion. And in the comments, tell me your favorite Monster Hunter monster, because maybe I will cover it in a future video. And endemic life count too. I'm not looking over the little guys.